Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look at the creation of a game making use of Windows API calls. Today we're going to create a simple game. However, this is not for the purposes of creating a game, it's more for the illustration of some Windows API calls. And using these within an application is the best way to demonstrate how they work. So let's jump right in and start to create our game. As with all applications, there are going to be some constants we'll have at the beginning of our application. So we'll set these up now. So we're going to create a small dialog on the screen, which is going to have a board width of 12 squares and a board height of 20. And our block size is going to be 25. Within this dialog, we're going to have a timer, which is going to trigger every 500 milliseconds. And we're going to have a number of blocks falling down from the top of the dialog. And we'll set our constant to have 7 blocks. As we're going to be referencing these 7 blocks within the application, we're going to set up a constant for each block to make it more readable. We can do this quite easily by using an enumeration. So we set up piece type as our enumerator, and we're doing this with the singular word, which means every constant name that follows will increment from the one before. So we've got the first one set as piece I, equal to the value of 1. So piece 0 will be the value 2, and so on. Within our application, these constants will appear with the percentage sign at the beginning of the name. And as you'll probably guess, we're going to create a number of global variables to be used within the application. As we're going to have a dialog on screen, we'll set a global value for the handle of that dialog. And on our game board, this will be a global array of long values. And then we have a number of other global variables which we'll cover as we come to them. So within our game, we're going to have these blocks dropping down from the top of the dialog. So we'll need some way of defining the shapes of each block and also their colors. So we're going to set up 2 global arrays to be used for those purposes. Now that we have all that in place, we can create our dialog. So here is our dialog new command. We're using dialog new pixels. This means we can specify the location of everything right down to the pixel to give us complete control of what appears where on the dialog. And we have a callback function which we've defined as cb_dialog_proc. We'll create that in a moment. As you will see, when we have created our dialog, we are populating our global handle for the dialog so we can use it through the rest of the application. We're also setting our global variable GameOver to the value false. Once the application realizes that the game is over, it will set this variable to true, which will stop the game running. So we have created 3 global arrays, one for the game board, one for the definition of the block shapes, and one for the colors of each individual block. So we will need to dimension these arrays right at the beginning. So we'll do that at the beginning of our PB main function. So here are our definitions of each of the global arrays. One for the game board, using the board width and height constants, one for the block shapes, using the max blocks constant, and one for the colors, again using the max blocks constant. Having these constants in the application makes it easy to expand the game and change the size or shape of the board based on just the value of these constants. So now that we've created the dialog, the next thing to do is to handle our callback function, our event handler. This function here. This function is going to be used to handle anything the user does to interact with the application, mainly by pressing buttons on the keyboard. So we're going to set up some local variables at the beginning of this function to be used within the body of the function itself. And again, we'll cover these as we come to them. So we're going to need a select case statement here to handle each of the types of messages that the dialog will trigger. So our select case is working on the CB message value. And the first thing we're interested in is the initialized dialog event. This is triggered once when the dialog is created. So as we're going to be using some random numbers within the application, our first task is to set the random number seed. This can be done quite easily by using the randomize timer command. Timer is the number of milliseconds since midnight. As this is constantly moving, every time we run the application, we will get a new seed. As you will remember from the beginning of our source code, we're going to be using a timer within this application. This to trigger every 500 milliseconds. So in this initialize dialog section, we're going to start the timer using a Windows API call called setTimer. It takes a number of parameters. The key ones are the handle of our dialog, the timer ID, and the interval of the timer. In this case, we've set the drop interval constant to be 500 milliseconds. So there is also going to be a timer event within this function. We'll populate the code in the timer shortly. So in our initialize dialog, there are a couple of other things we'll need to do. First, we'll need to create the shapes that are going to be used in the game. And having done that, we'll then have to initialize the game. This will need to happen before the timer triggers. So we'll put this code before the call to set timer. So we're going to create two new subroutines, one to initialize the shapes and one to initialize the game itself. So we'll handle the initialize shapes first. So one of the first things we'll want to do within this subroutine is to define the colors of our 7 blocks. So we'll create a separate function whose job it will be to set those up. And we'll come back to the subroutine in a moment, but let's first delve into defining the block colors. As you will remember from the beginning of the application, we have 7 distinct shapes we want for our blocks. So here are the constants we had set up at the beginning of the application. So we have a global array to hold the color values. So we're going to set the very first element in this array, the 0 element, to the color black. We're using the RGB inbuilt function to set the red, green and blue values all to 0, which gives us effectively the black color. And for each of the pieces, we're going to give a different color. For example, for the first one, we're setting a value which is only green and blue, and gives us effectively a cyan color. And for each of the other blocks, we're setting a slightly different color. Using the RGB command gives you full control over the 255 shades of each of the colors. So there are all 7 blocks now set with a specific color. So now with the colors defined, we can go back to our subroutine. So we're going to set some local variables up at the beginning of our subroutine to allow us to use for next loops to step through each of the elements within our blocks shape array. And it's also good to ensure that we've cleared out anything in the block shapes array already. We could do that with a for next loop, but we can do it quite easily using the reset command, as this is a numeric array, and using the reset command will set all values within this array to the value 0. This allows you to reset it without much typing. So we'll now have to step through each of the different block types and set the values. As you have seen, this is one of the rare uses of 4-dimensional arrays. The first element is the block type we're actually handling. And we also need to handle the rotation of the block, because within the game, the users playing can rotate blocks to make them fit better into the bottom of the screen. So we're defining the areas within our array where a solid block appears. So these are all set to the value 1. For this particular piece, it's very straightforward, as it only has 2 rotation shapes, either horizontal or vertical. The next piece, which is a square, can be rotated, but it looks the same in every rotation. So we only have to set 4 values. And we will duplicate those values through the rest of the part of the array which this data is held. We can do that quite easily by using a nested for next loop. And we can now step through each of the remaining blocks to define where the shapes appear for each of the rotations. This is quite laborious to set up, but you only have to type it once. So now that we have completed the initialize shapes subroutine, we now have to go on to the initialize game subroutine. This is going to be a very straightforward routine. Within this, our first task is to clear the game board. Again, we can use the reset command to set all the values within the game board array to 0. Next, we want to blank out the score for the player, the number of lines they have completed, and mark game over to be false. The next part of the code in here would be to set the next piece to appear, and we'll pick a random number between 1 and the maximum number of blocks, which is 7. The next call within this subroutine would be a call to create the next piece to appear on the screen. However, we'll do that in a moment. First, I would like to test the application to see if it compiles cleanly, which in this case it does. If we attempt to run the application, we will get a blank screen. That's ideal as it proves our application will actually function. So let's get back to the code. So we will create a new function called spawn new piece. This will create the new block at the top of the screen, getting it ready to bring into the game. We won't complete this subroutine just yet, but I'm going to nip back to the event handler. In our event handler, we have code to handle the initialization of the dialog, but nothing in the timer. In the timer, we want to check to make sure that the game is not yet over. And just in case you have 2 timers running in your application, we'll need to test to make sure that the one that has been triggered is the one we're interested in. So we're going to put an if condition in here. This tests the w param value. If that's equal to our timer ID and the game over is currently false, then the game is still running and the timer that is triggered is the one we are interested in. If these 2 conditions are not found, then it's possible that the game is actually over. So we can put an else if in to test the game over global variable. If the game is over, we can kill and therefore stop the timer. So far, so good. The other thing we want to put into our event handler is something to handle repaint events. Within the application, we're going to be triggering requests to repaint the dialog because something has been updated. So we're going to need an event which will handle that request. And here is our WM paint event. So we're going to wrap call to a new subroutine we have not yet created to begin and end the painting event. So here we have the call to begin paint and the call to end paint. These are Windows API calls. So the first event is begin paint. We are picking up the value of the return from begin paint and storing it in this handle, HDC. Begin paint takes 2 parameters, the handle of the dialog, a user-defined type called paint structure, and end paint takes the same 2 parameters. So within these 2 Windows API calls, we're going to make a call to a new subroutine to draw the game on the screen. And as you will see at the beginning of this function, we have defined each of these new local variables. HDC as a D word to be used as a handle, and PS as paint structure, which is one of the Windows API inbuilt user-defined types, specifically for this type of purpose. So let's now go and create the draw game subroutine. As you will see, this subroutine takes a single parameter, HDC, which is the handle returned from our begin paint function. So as you can guess in here, we're going to be drawing the game board. And we're going to need some local variables. The very first task we need to do within this subroutine is to clear the background. And we're going to be calling a few Windows API calls in here. So the first one will be to get the client rectangle. This is the location on screen where a dialog resides. So this takes 2 parameters. Firstly, you'll recognize the handle of the dialog when we created it. The second parameter is a user-defined type, which is populated by this Windows API call to say exactly where on screen our client rectangle actually resides. Next, we want to create a brush. This is going to be used as the colour we're going to be filling in this rectangle. And again, we're using the RGB command to specify the actual colour we're going to be using. Next, we're going to call another Windows API call to fill this rectangle in. This takes 3 parameters. First of all, the variable which we passed in to this function as our device context handle. Next, we're giving it the rectangle which we populated a moment ago. Finally, we're passing it the handle of our brush, which defines the colour we're going to be using to fill the rectangle in. This performs the fill on screen. Next, we can then delete the object we created for the brush. This frees up any memory Windows was using to perform this API call. So now that we've cleared the background, we can now attempt to draw the game board. And we're going to use a nested for next loop for this one. So we're going from 0 to the board width -1 and from 0 to the board height -1. So we're going to be looking at the game board array. At the moment, this is completely blank, but during the game, this will start to get populated. So we can pick up the value that's sitting on that game board. This tells us what kind of block we're dealing with. And next, we're going to determine what colour we're going to be using. If the block is greater than 0, we're going to do another call to create solid brush. And we're going to be populating that with the colour that's defined in our global array of colours, which will give us a colour for that specific type of block. Otherwise, we're setting a colour using RGB as 64, 64, 64. So now that we've defined the colour of the block to be drawn on screen, we can now use our user-defined type to populate the left, top, right and bottom coordinates. And again, we're using the prefix command here to make our coding look a little tidier. So now we've populated the values for our rectangle, we can now call the fill rectangle API call, which is the one we used earlier to blank out our dialog. And after having filled our rectangle, we can then delete our brush. So now that we have that in place, to make it look neater on screen, we'll want to draw a border around the rectangle we have just created. And we're going to use 2 new Windows API calls to perform this function. One called move to X and one called line to. The move to X will actually move to the location we want to do something with. And then the line to command will draw a line. So hopefully this has drawn the border around each of our boxes. So if we run the application now, we can see the bare board. Here we have the grid of 12 by 20 boxes. So that piece of code is working quite nicely. We have yet to draw the actual game blocks on the screen, and we can do that as the next section of this subroutine. First, we'll need to test to see whether the game is over or not. We'll put the code in this if block in a moment, but we'll move down to what happens after. Each time this subroutine is called, we'll want to draw on the screen the score and the number of lines that the user has completed. So we're going to be using some more Windows API calls here. The first thing we're going to do is to set the text colour. Again, we're using RGB to define white as the colour we wish to draw on the screen. And we're setting another Windows API call, set background mode, to make this transparent, so the background behind the text will show through. So first, we will set the value of the current score, using our global variable in which that value will be stored. And in this case, the str text variable is a specific type for Windows API calls. As you will see from the beginning of the function, we've created this as an ASCII Z times 20, which is a null-terminated string of 20 characters in size. Should you need to put more text into it, you just have to increase the size beyond 20. So we can then use another Windows API call called textOut to place our characters on the screen. it takes a number of parameters, the first being the handle of the device context, then the X and Y coordinates where you wish your text to appear. The next parameter is our variable holding the text, score and the value, and the final variable here is the length of text. You need to give this to the Windows API call to tell it how many characters you're going to be printing on screen. And having done that for the score, we can do exactly the same for the number of lines. These will be the number of lines the user has actually managed to complete by having blocks on all of them. So if we run the application now, we will see those values appearing on the screen. We have the word score and the value 0 and the number of lines as 0. So in the event that the game has actually been completed, you'll want to tell the user that the game is now over and give them the option to restart the game. So we're going to use a test for game over and then use the commands we just used to set values on the screen for text. So if and only if the game is actually over, will the words game over appear on screen. And then we will put a message up to say press the letter R, either uppercase or lowercase, to restart the game. So now we can look to draw the current piece if the game is not over. And again, as we've done before, we'll want to pick up our brush and define the colour that we're going to be using. And we're calling on the values held within our global array of colours for the current piece we're actually handling. And again, we're going to use a nested for next loop. And within this loop, we're going to be looking at the block shapes. And as we said before, this is one of the few occasions where I've used an array that has 4 dimensions. The first being the current piece. This is the type of block we're actually handling. The next 2 parameters are the X and Y, and finally the current rotation. As the user is going to be allowed to rotate these blocks during the game, the rotation is important. Next, we'll need to do some testing. If the current Y plus the new value of Y is greater than or equal to 0, then we can populate our user-defined type. And then we can use the fill rectangle Windows API call to fill in our colour. And as we did before, we'll want to draw a border around it, which is exactly the same piece of code as we did before. So if we test run the application now to see if it will draw the first piece. And there we have a piece on screen, which in this case is coloured white. So what we need to do next is to complete the spawn new piece subroutine. We're going to populate a number of global variables here. We're going to set the current piece equal to the next piece. The next piece is then equal to a random number between 1 and the maximum number of blocks. So we'll give us a value of between 1 and 7. Next, we'll need to position the X coordinate that it will appear at, which we're calculating to be the board width divided by 2 minus 2 squares. This will position our shape at the middle of the board, and its current Y value is -1, so it's not quite on the board, but it's very close to the edge. And the current rotation is 0, so the shape is not yet rotated. In order to determine whether the position is valid or not, in other words, can we position this shape on the screen, is there room for it, we need to create a new function called isValidPosition, passing it these 4 pieces of information. If this new function returns the value false, it means we cannot position our shape on the screen. Therefore, the game is over. So let's now go and create the isValidPosition function. So here is the skeleton of our new function, taking its 4 parameters. So this function needs to determine whether the block shapes will actually fit. So again, a nested for next loop. And if we get to the end of this for next loop, then the position is considered to be valid, and the piece can be placed on screen. So we're going to put a series of tests in here to make sure that the piece can fit on the screen, there is room for it, and it's not running off the side or the bottom of the board. And again, we're using the blocks shape global array to determine whether this is true or not. So we now go back to the callback function of the dialog, the event handler. In here we have the timer. When the timer is triggered, we can then determine, using the function we have just created, if we can place the piece on the board or not. So if this function returns true, we can then increment our current y coordinate. And if not, we then have to do some more logic. We're going to create a new function called placePiece. We'll come back to that function and create it in a moment. But we'll push on inside this function to complete it. Next we need to determine have we actually cleared a line or not. And we'll create a new function whose job it is to work that one out. And we will up the value for the score and the lines in our global variables. And then we will make a call to create the next piece, using the spawn new piece function we created earlier. In order to trigger a WMPaint event, there's another Windows API call we can actually use. This is one called invalidateRectangle. We'll be using this a number of times throughout the application. This takes 3 parameters. The key parameter here is the first one, which is the handle of our dialog. Basically, we're telling Windows that it needs to trigger a repaint event for the entire dialog. So let's now first of all go and create the placePiece subroutine. Again, this is going to involve a nested for next loop. And we're going to be looking into our block shaped global array once more. And if this is a value 1, we can then go on to the next piece of code. And if this comes back as true, then we can then update the game board with the current piece. So we now have to create the clear lines function. So here is the skeleton of our new function, and this one takes no parameters. So we assume the value for clear lines is 0. Do we have a fully completed line? And in this case, we'll have to search through each of the rows and columns within our grid. And we'll assume initially that the line is fully populated. And we'll step through each of the cells of the game board array to see if any of them are 0. If any of them are 0, then the line is not complete. And if that's the case, we can exit this for next loop with the value of full line being equal to 0. We can then test the value of full line. So if this is a full line, then all the lines above can move down. So again, another nested for next loop. And having moved all the lines down, we need to clear the top line. And finally, we can increment the variable for cleared lines and increment long y so we can check this line once more. And the output from this function is the value held within cleared lines. So if we run our application now, we're getting there. The colours aren't quite right, but the shape is moving down the screen. And a new shape is triggered. And the first cell is populating with a colour, but the other cells are not populated. So we're missing a value somewhere. But the game is taking shape. So let's see if we can find that bug in the application. Now I think I've located the problem. After we filled a rectangle in this function here, which draws the piece on the screen, we are deleting the brush. And that should not be in there. That should be after the for next loop has completed. So let's try running once more. And that's better. Our colours are now appearing quite correctly for the entire block. So in summary, what we've achieved today is we have created a game map which is driven by a number of Windows API calls, including a timer. We have some flickering on the screen, but we can sort that out later. We have the different types of blocks appearing on screen, and they fall down the screen to the bottom of the grid. We have a score and a number of lines completed on the left-hand side. What we still have to complete is to allow the user to move these blocks and rotate them. However, we'll do that in the next video. That's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.